This is a short video on linear programming, which has applications in statistics and applied mathematics. Linear programming is a method of solving problems in which a quantity represented by a linear equation is to be maximized or minimized subject to a system of linear inequalities. So everywhere we use only linear equations and inequations, hence the word linear programming. The linear function ax plus by plus c, whose maximum or minimum is to be determined, is called the objective function. The system of inequations involving the variables of an LPP are called the constraints. The common region determined by all the constraints is called the feasible region, and every point in the feasible region is a feasible solution. So one advantage of this topic is that there are no formulae to remember. You only need to see you have the optimal function, which is ax plus by plus c. Then you have the constraints, the feasible region, and the feasible solution. So there are three parts of solving problems in LPP. The first is formulation, the second is drawing a graph and finding the feasible points, and the third one is putting both together and finding the optimal point. So going to the first problem, that is how to formulate an LPP. A furniture dealer deals in only tables and chairs. He can invest up to rupees 50,000 only and has a storage capacity of 100 pieces. His cost price of a table is rupees 1,200 and of a chair is rupees 500. He can earn a profit of rupees 180 on the sale of a table and rupees 75 on the sale of a chair. Assuming that he can sell all the items he buys, formulate an LPP problem so that he can maximize the profit. So we start with let x be the number of tables, y be the number of chairs. Cost price of a table is 1,200, cost price of a chair is 500, maximum investment is 50,000. So this is the data given to us. Now the storage capacity, going back to the problem, he can invest up to rupees 50,000. So we have 1,200x plus 500y less than or equal to 50,000, because cost price of a table is 1,200, cost price of a chair is 500. So cost of x tables plus y chairs will be maximum 50,000. The storage capacity is for 100 pieces. So we have x plus y less than or equal to 100. And since the number of tables and chairs cannot be negative, we have x greater than or equal to 0, y greater than or equal to 0. So putting these together, the problem reduces to maximize z equal to 180x plus 75y. That is because we are given that he can earn a profit of rupees 180 on the sale of a table and rupees 75 on the sale of a chair. So we have maximize z equal to 180x plus 75y. Maximize because we need to find the maximum profit. Subject to these constraints, 1,200x plus 500y less than or equal to 50,000, x plus y less than or equal to 100, x greater than or equal to 0, y greater than or equal to 0. Now coming to the next problem, how to draw the graphs and find the optimal points. Minimize z equal to x plus y subject to 3x plus 2y greater than or equal to 12, x plus 3y greater than or equal to 11, x greater than or equal to 0, y greater than or equal to 0. Now the line 3x plus 2y equal to 12 will intersect the coordinate axis at 4, 0, 0, 6. If you put y as 0, x is 4. And if you put x as 0, y is 6. X plus 3y equal to 11 will intersect the coordinate axis at 11, 0 and 0, 11 by 3. So these would be the points. This is the line 3x plus 2y equal to 12 and this is the line x plus 3y equal to 11. Now we have 3x plus 2y greater than or equal to 12. So if I put x as 0, y as 0, we get 0 greater than or equal to 12, which is not possible. So we shade the region to the right of the line, not the region which has 0. Similarly, x plus 3y equal to 11, we would shade the region to the right of the line which does not have 0. So this shaded part would be the common feasible region to both the lines. So you can see the corner points are 0, 6, 2, 3 and 11, 0. and your optimal function is z equal to x plus y. So at 0, 6, z will be 0 plus 6, which is 6. At 2, 3, z would be 5. At 11, 0, z would be 11. And we need to minimize z. So minimum z will be equal to 5 at 2, 3. Now we will see how to put both these problems together. Going to the next question, a company produces two types of items P and Q. Manufacturing of both items require the metals gold and copper. Each unit of item P requires 3 grams of gold and 1 gram of copper, while that of item Q requires 1 gram of gold and 2 grams of copper. The company has 9 grams of gold and 8 grams of copper in store. If each unit of item P makes a profit of rupees 50 and each unit of item Q makes a profit of rupees 60, determine the number of units of each item that the company should produce to maximize profit. What is the maximum profit? So we start with let X be the number of units of type P, Y be the number of units of type Q. We need to maximize Z equal to 50X plus 60Y subject to, because if you look at the question, the profit on item P is 50, item Q is 60. And putting the question in the form of a table, we have item P and Q, gold and copper. P has 3 units of gold, 1 unit of copper, profit is rupees 50. Q has 1 unit of gold, 2 units of copper, profit is rupees 60. And the company has 9 grams of gold and 8 grams of copper. So we would have 3x plus y less than or equal to 9, x plus 2y less than or equal to 8. And the non-negativity constraint, x greater than or equal to 0, y greater than or equal to 0. So putting these together, x plus 2y equal to 8 would intersect the x-axis as 8, 0, y-axis at 0, 4. 3x plus y equal to 9 would intersect the x-axis at 3, 0, y-axis at 0, 9. We have x plus 2y less than or equal to 8. So if you put x as 0, y as 0, 0 satisfies the inequation. So we would shade the region to the left of the line. Similarly, 3x plus y equal to 9, we would shade the region to the left of the line. So this would be the common feasible region to both the lines. So the corner points would be 0, 0, 3, 0, 0, 4 and 2, 3. So prepare a table with the corner points and your optimal function is z equal to 50x plus 60y. At 0, 0, z is 0. At 2, 3, if you put z as x as 2 and y as 3, we would get z as 280. At 3, 0, z would be 150. And at 0, 4, z would be 240. We need to maximize the values. So maximum profit is 280 for 2 units of type P and 3 units of type Q. Thank you for watching this video. For more help in math-related topics for class 11 and 12, you can contact me on matthews.suman@gmail.com. Thank you.